The roots of the equation x cubed minus 7x squared plus kx minus 15 equals 0 are R1, R2, and R3. It is given that one of these roots is 2 plus I. Find the other two roots. So to find the other two roots, first of all, by the conjugate root theorem, the conjugate of 2 plus I, which is 2 minus I, is also a root. So now we have two of the three roots, we just need the third one. And to find the final root, I'm going to use the sum of the roots of a polynomial. So the sum of the roots of a polynomial, R1 plus R2 plus R3, is equal to minus 1 to the power of, in this case, 1, because it's like one thing being multiplied together at a time. The denominator is always the leading coefficient, which is 1, and we step 1 back from it, so it's minus 7. So we have minus 1 times minus 7, which is 7. That means that 2 plus I plus 2 minus I plus the third root is equal to 7, which means the 2 and the 2 give us 4. The I and the minus I cancel out, which means R3 is going to be equal to 3. So the third root is 3. So 2 plus I, 2 minus I, and 3 are our three roots. Hence or otherwise find the value of k. Now we could write this out by writing out x minus 2 minus I times x minus 2 plus I times x minus 3 and expanding that, and we can work out k by using that. That's a perfectly valid method, but I'm going to show you another method using the sum of the roots here. Now k is in the position where it is 2 back from the leading coefficient. So that means it's related to when we multiply pairwise the roots. So R1 times R2 plus R1 times R3 plus R2 times R3 is equal to minus 1 squared times the denominator is 1 and the numerator is k. So it's equal to just k. So k is equal to whatever this sum is. So that is 2 plus I times 2 minus I plus 2 plus I times by 3 plus 2 minus I times by 3 is equal to k. This one's going to give us 4 minus I squared, which is plus 1, so 5. This one gives us 6 plus 3i. This one gives us plus 6 plus, minus 3i is equal to k, which means k is equal to 5 plus 6 plus 6, which is 17. So k is equal to 17. This would have been a perfectly valid method to do it as well. You could have expanded this out and you would have got to 17 too. It would have worked. It's just a matter of personal preference. I thought I would show you this method as another way to approach this particular problem.